Good day, and welcome to CFE Media's Virtual Training Week. For this session on how to measure electrical safety program effectiveness, we'll be joined by Lanny Floyd of the Electrical Safety Group. Following his presentation, Lanny will participate in a live chat session in which he's available to answer your questions. Today's presentation can provide continuing education credits. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of this program will be reported to RECEP at recep.net. A certificate of completion will be available for each participant to download upon successful completion of a test at the end of the presentation. As such, it does not include content that may be deemed or construed to be an approval or endorsement by RECEP. Contact with or exposure to electrical energy is a leading cause of occupational fatalities. Yet lost time electrical injuries are among the rarest injuries in the workplace, contributing less than 0.2% or 1 in 500 of all workplace injuries. These two attributes, low frequency and severe consequence, create a serious challenge in measuring an electrical safety program's effectiveness. The traditional measurement of injury rates is a lagging indicator and may blind an organization to future potential for an electrical injury, since the low frequency of electrical injuries may mean having insufficient data points for statistical validity. This presentation explores opportunities to complement traditional methods of measuring safety performance with leading indicators to drive continual improvement in reducing electrical injury risk. It will incorporate recent advances in regulatory guidance and voluntary standards in safety performance measurement. You see before you some of the learning objectives for today's session. Here are some tips to help you get the most from today's session. I'd now like to introduce today's speaker. For more than 50 years, Lanny Floyd has pushed the envelope when it comes to managing the risk of electrical injuries in the workplace. His 45-plus year career with DuPont focused on electrical safety in the construction, operation, and maintenance of DuPont facilities worldwide. This included improving management systems, competency renewal, safe work practices, and the application of technologies critical to electrical safety performance in all DuPont operations. In 2001, Floyd established Electrical Safety Group Incorporated to provide expert consulting in electrical subject matter. In 2013, the University of Alabama at Birmingham invited Lanny to join the faculty of the Advanced Safety and Engineering Management program in the School of Engineering. In this capacity, he created and teaches the course Electrical System Safety. Expert consultant, author, speaker, and educator in occupational electrical safety, Lanny is an IEEE Life Fellow, professional member of the American Society of Safety Professionals, a certified safety professional, electrical safety compliance professional, maintenance and reliability professional, reliability leader, and a registered professional engineer in Delaware, Michigan, Pennsylvania, and Texas. Lanny, thanks so much for joining us for today's session. The floor is yours.
Thank you, Kevin. This is a real pleasure to be able to spend some time with your audience today. As Kevin introduced me, he noted that I've been involved in some aspect of advancing electrical safety for over 50 years. So in this presentation today, titled Measure Electrical Safety Program Effectiveness, I've brought together my career experience, along with the latest research and practice in monitoring safety performance through advanced safety metrics. Okay, so a fundamental question is, how do we measure the quality and effectiveness of our electrical safety program? Now, on the right-hand side, I've got a collage of codes, regulations, and standards. The OSHA regulations, in particular 1910 subpart S, the National Electrical Code, which covers minimum installation requirements, the National Electrical Safety Code, which addresses electrical safety installation requirements related to electric power and telecommunication systems. We have NFPA 70B, which is the recommendations for electrical equipment maintenance. IEEE 1584, which is the guide for performing arc flash energy calculations. We have two IEEE standards, IEEE 3002, 3007.2, which is the guide for electrical equipment maintenance for industrial and commercial power systems. IEEE 3007.3, which is the guide for safety and industrial and commercial electric power systems. And of course, we have NFPA 70E, which is widely known as the standard for electrical safety in the workplace. Now, most of us that have electrical safety programs for our facilities use some or perhaps all of these standards to develop the electrical safety program for our facilities and our operations. But how do we measure the effectiveness of the electrical safety program? You won't find the answer to that in any of these codes, regulations, and standards. We have to look elsewhere to answer that question. Just implementing and being in compliance with those codes, regulations, and standards is not enough. How do we measure the effectiveness of our implementation? So what is safety performance? Many organizations use the bottom line of safety or injury rates, such as the total recordable injury rate, or some people may call it the OSHA recordable injury rate, or they may call it the lost time injury rate. And they may have other metrics. There's a metric called the DART rate, which is the days away from work, and restricted time rate, which is a measure of severity. These are lagging indicators. These tell us what happened in the past. They may not tell us what is going to happen in the future. But another question, is the absence of injury the same as being safe? Another way to think about that is, if we didn't have an injury last year, does that mean we're not going to have an injury next year or this year? Now, Todd Conklin is a recognized thought leader in safety management. One of his quotes was that safety is the presence of controls. Compare that to the previous question. Is the absence of injury the same as being safe? Again, Todd Conklin says, no, safety is the presence of controls. ISO 45001 is a safety management standard. It was published in 2018. It's considered one of the most advanced standard around safety, occupational safety and health management. Has this statement: safety performance involves ongoing and continual risk reduction. All right. It's not just a compliance with a regulation or standard, it's ongoing and continual risk reduction. So how do we measure the presence of controls? How do we measure ongoing and continual risk reduction? You know, whether we're an individual, we're asking that question, or we have a electrical safety committee or electrical safety team that is concerned about electrical safety in your facility. Again, our programs are built around these codes and regulations, and maybe others shown here on the right. But again, as I mentioned earlier, these codes, regulations, and standards don't tell us how to measure the quality of implementation. How good are we at the ongoing and continual risk reduction? All of us have seen one time or another scoreboards similar like to the one on the left-hand side here, where it says, in this case, this department has worked 214 days without a lost time accident. The best previous record was 736 days. Do your part, help make a new record. Now these are lagging indicators. The fact that we've gone 214 days without a lost time injury tells us what's happened in the past 214 days. That information does not really tell us what's going to happen later today or tomorrow or next year. But these lagging indicators have been very popular in the past, and they're very useful and they're important. They're easily collected and analyzed. They're easily understood and measured. They help show progress toward a goal. You know, we're 214 days toward our best previous record of 736. And when we meet a new goal, our rituals tend to, we want to celebrate. We've made progress, or at least maybe we think we've made progress. April 20th, 2010, in the Gulf of Mexico, the management of this company that owned the oil company was actually on the platform to help celebrate 7 years without any lost time injuries, 7 years with 0 lost time injuries. On that very day that they were celebrating achieving this milestone, this accident occurred in which 11 people were killed, 14 people were injured, and was the worst environmental disaster in US history. Think about that. The lagging indicator didn't predict what was going to happen next. Is there a better way to do this? Well, this is particularly true and very important when we think about electrical safety. This pie chart is the lost time injuries that occurred in the United States in 2019. This is from the US Bureau of Labor Statistics data. There were about 890,000 total lost time injuries in 2019 in the US. And if you look at the legends on the right-hand side and match it up with the pie charts segments, the blue segment in the upper right, a little over a quarter of the injuries were due to sprains, strains, and tears. In the lower right, an orange color there, this is about a quarter of the injuries, they were musculoskeletal disorders. And in the lower left, the gray area, about a fifth of the injuries were slips, trips, and falls on the same level. That's almost about two thirds of the total of the lost time injuries that occurred in 2019. And so this occupies a lot of energy and effort by most organizations to manage their total recordable injury rate. But a characteristic of these three categories, plus a few others, are that they have low likelihood, low credible potential for being fatal or being permanently disabling. Now, up at the top, and I've created this boxed area at the top. These are injury scenarios that are considered low frequency, but very high consequence. In that, if you look at the enlargement in the upper right there, there's a tiny red sliver at the 12 o'clock position on this pie chart that is representative of the electrical injuries from shock and arc flash that occurred in 2019. That's, as Kevin mentioned in the introduction, that's less than 0.2% of the lost time injuries that occurred in 2019. And this is very much representative of at least the last decade, that electrical injuries are less than 0.2%. Another way to look at that is less than 1 in 500. So they're very low frequency. So you could almost ask the question, why are we even concerned about electrical safety? Well, there's a two-sided coin here. On one side of the coin, they're very low frequency. On the other side of the coin, they're very high consequence. 1 in 12 of these lost time injuries from electrical exposure are fatal. That's an extremely high likelihood of an electrical injury to be fatal. And those that are not fatal can have very serious long-term disabling injury characteristics associated with them. It's the 7th leading cause of fatality in the US, occupational fatality, that is. And it's the 2nd leading cause of occupational fatality in the construction industry. Extremely high consequence in the construction industry. And also it's the reported by Liberty Mutual several years ago, one of the large workers' compensation carriers in the US. Electrical injuries tend to be the second most costly workers' compensation claim. Now, the three people over on the left-hand side that are blinded, what I'm trying to emphasize here is that the low frequency side of this coin can blind an organization to the likelihood of or the risk of an electrical injury in their organization. What this can mean is that an organization can not have an electrical injury for a long time, not have a fatality for a long time, and that can create an illusion of control. And the organization can think that the quality of its electrical safety program is what is contributed to not having an electrical injury for a long time. But in reality, it's not the quality of the program. It's just the fact that electrical injuries tend to be very low frequency. And then one day, an serious electrical injury or fatality occurs, and the organization comes together and they ask, how could this have happened? We've never had an electrical injury before. We haven't had one for a long time. This individual has never had an electrical injury before. He or she is the most knowledgeable person in our organization. How could this have happened? Well, that's an example of being blinded by the data. The low frequency nature of electrical injuries can blind you to your risk. Now, these two charts are looking at the occupational fatalities from contact or exposure to electrical energy. These are fatalities. The top chart is looking at 1980 to 2018. And you can see there's been a long-term trend, downward trend. Early in my career, I was over on the left-hand side, and we were experiencing about 600 occupational fatalities from electrical energy every year. Now, the use of electricity has expanded dramatically. Our workforce has expanded significantly, and yet we see we have a downward trend in the absolute number of electrical injuries. But again, there's a story on the right-hand side, and that story is shown in detail by the bottom graph. And this bottom graph is courtesy of the Electrical Safety Foundation International, who over the last number of years have analyzed the BLS data each year and given us analysis of what's going on in electrical safety injuries and fatalities. And we can see that from 2011 into 2019, that fatality trend is really essentially flat. So this raises some questions, at least in my mind, and maybe in yours. Why is this flat? Have we reached the practical limit of our ability to reduce electrical injuries? Is there something else going on that could help us turn this trend further downward? Well, fortunately, the answer to those questions have been partially answered by a study that was published in 2014, and I'm showing the first page there on the left-hand side. And we can see that this study titled Occupational Fatality Risk in the United States and the United Kingdom. The researchers were John Mendelhoff and Laura Statsky. This study was published in the American Journal of Industrial Medicine in 2014. Now, I've underlined one sentence, or part of one sentence there on the left. It says, in 2010, the fatality rate in the UK was about 1/3 the rate in the US. And this is not just for electrical fatalities. This is for all occupational fatalities, okay? And over on the right-hand side is a chart that's contained in the report, in this study. And this is looking at various hazard exposure scenarios and showing the UK fatality rate, the US fatality rate in the second column, and then the ratio of those two in the right-hand column. And you can see at the very top is contact with moving machinery. The UK rate 0.06, the US rate 0.20, and the ratio is 3.3. In other words, more than 3 times more likely to have a fatal injury in the US from contact with moving machinery than in the UK. Now, in the middle, we have falls from height. And we see a UK rate of 0.17, a US rate of 0.50, and a ratio of 2.9, almost 3 times greater in the US than in the UK. Then in the down at the bottom where I have the red arrow, we have contact with electricity or electrical discharge. I have a UK rate of 0.037, a US rate of 0.14. This is per 100,000 workers. I believe that's the ratio. I may be, it's in the paper, but anyway, that's what that rate is. And we see a ratio of 3.8, almost 4 times more likely to have a fatal electrical injury in the US than in the UK. Now, if you read the paper, the research paper in detail, you see that the data includes not only the UK, but all of the countries in the European Union. And I can say that all of the countries in the European Union have a lower fatality rate from exposure to electrical energy than the US. So it partially answers a previous question I had. Are we at a practical limit of being able to turn that trend, that flat trend in electrical fatalities further downward? So we can see that other countries have found ways to do that. How have they done that? You know, there are many questions around that, and it's probably not a single answer to that question. But if you read the article, it raises some possibilities, and it's been addressed by OSHA. This was a statement to this OSHA staff by Assistant Secretary David Michaels. He issued this statement in July 2010, over 10 years ago. He said that ensuring that American workplaces are safe will require a paradigm shift, with employers going beyond simply attempting to meet OSHA standards to implementing risk-based workplace injury and illness prevention programs. Now, I'd like to stop there and talk about a few things. What do we mean? What did he mean by risk-based approach? Some people mistakenly think that that means that we want to take more risk. Well, no, that's not what that means. A risk-based approach is a safety culture in which you are continually looking for, identifying, and reducing risk to a lower level than you've done in the past. Okay, it's an ongoing and continual program to identify and reduce risk. Now, he referenced OSHA standards. It's not just the OSHA standards. The other tools we use to help manage our electrical safety programs, that collage of codes, regulations, and standards I showed earlier. It's not, in order to achieve the safest possible workplace, we can't just be content with being in compliance with those codes and standards. All right. It's not enough that you feel like you're in compliance with NFPA 70E, or in compliance with the National Electrical Code, or in compliance with the IEEE standard on arc flash energy assessment. All right. Need to be asking the question, what is the remaining risk? Now let's talk about risk for a few minutes. And specifically, I want to talk about hard risk and soft risk. Now, over on the left-hand side, we see a photograph of a great white shark. Now, imagine for a moment that you're in a boat and you're hanging over the rail and you're about 10 feet from the open mouth of the great white shark. And if you were in that situation, it would be very obvious that you were face to face with a clear and present hazard. And if you were to get any closer, you would stand to lose one or more body parts, and that would be a very bad thing. All right, that's a hard risk. It's easy to sense that the risk is present and real and likely to cause serious harm. All right. Now, over on the right-hand side is an example of what I'll call soft risk. A soft risk is a risk when you don't have a hard line to the clear and present danger, but it impacts the risk. Now, they could be having a conversation about, do we want to go for a boat ride today? And if they decide to stay on the dock, then that would be obviously, they would have no chance of coming face to face with a great white shark. If they decide to go for a boat ride, they probably won't come face to face with a great white shark, but it increases the risk that they could. All right. So it's a soft risk. It's not, the clear and present danger is not there. All right. Well, let's look at an electrical example. Now, over on the left-hand side, we see a worker performing a task on some electrical equipment that appears to be a high voltage, high energy situation. And so that's an example of a hard risk. The person is close. They've recognized the danger. They've got on the proper protective equipment. They're using a proper tool to do the task they're doing. And so there's been recognition that there's a clear and present danger. The hazard is there. The risk is hard. All right. Now, over on the right-hand side, imagine that these people sitting around the table are doing a design review for the electric power system infrastructure for the facility, for a new plant, for example, or an expansion project for an existing plant. And they're having conversation about the design of the system, maybe about the selection of equipment. Maybe they're looking at optional features to equipment that could reduce exposure, reduce risk. So they're making some, in this conversation, they're making some decisions. And those decisions will impact the risk that the workers would have in that facility for the life of the facility. But it's not a clear and present danger. It's very difficult to see that there's a hazard right there. Okay, but their activity, their interaction impacts risk. This is a soft risk. All right. Now, the reason I wanted to introduce this concept of soft risk is that soft risk provides many opportunities to identify leading indicator metrics that we can use to complement the lagging indicators that we're so used to using. For the organizations that haven't had an electrical injury for a long time, maybe have never had an electrical fatality in their organizations or in their memory, for an individual who hasn't had an electrical injury for maybe in his or her career, how do we look beyond that zero to really understand what is the risk that we may be facing every day, and is our effort to reduce that risk as good as it can be? Again, looking in the rearview mirror, like in the lower left there, where we can see where we've been in the past, we see where we come from, but that doesn't tell us where we're going. We need to be able to look as far into the future as possible to see where are those opportunities for continual and ongoing risk reduction, and be able to measure those so that we know if we're making any progress. Well, there's been some great work done in the last decade, and a lot just in the last few years, that has brought attention to this concern of the flattening trend in fatalities. Now, I showed you the chart of the electrical fatalities, but that same scenario is playing out in all of the hazards that have likelihood of being fatal. the trend in fatal injuries has flattened, even in this, and at the same time that recordable injuries have continued to be have a downward trend. And so this challenge that that Secretary Michaels issued in 2010 has been reflected and repeated, and we can see evidence of people paying attention to that and helping organizations move more toward a risk-based approach in managing safety. And that includes adding leading indicators to your management system. Now, ANSI Z10, which I'm showing the cover here on the right, ANSI Z10, the title is Occupational Health and Safety Management Systems. It's not just electrical management, it's managing all hazards. It was last published in 2019, and that revision included an expansion of the discussion around leading and lagging indicators. And this is what it had to say about leading indicators. It says that leading indicators provides insight into quality effectiveness of your safety management process. They can enable business leaders to identify and drive strategic actions. And they can help flag problems early and uncover the weakness in an organization's safety management processes and safety management procedures or safe work practices. Now, the Global Reporting Initiative published the standard GRI 403 titled Occupational Health and Safety in 2018. And that revision had this statement. It said that leading indicators measure an organization's performance in relation to the actions it takes to prevent work-related injuries and ill health. They are important because an organization cannot rely solely on lagging indicators, which might not give a true picture of their occupational health and safety performance due to issues such as latency, ill health, and underreporting. Now, these two things are very relevant to electrical safety, those two things at the end of the sentence: latency, ill health, and underreporting. A lot of people, when I talk with audiences around on electrical safety, you know, it's obvious. I get people making comments that they've been shocked many times without any apparent negative outcome, which may mean that there's underreporting of exposure to electrical injury. And in the area of latency ill health, there's been a lot of work in the medical field in the last decade or two on long-term health effects of exposure to electrical energy, electric shock, for example, that can result in cataracts on your eyes, can result in cognitive difficulties or nerve damage or muscle weakness. Those are examples of latent ill health consequences. All right. So if you're not, we have difficulty in capturing those in injury metrics because often there's no apparent bad consequence, no bad outcome at the time. All right. So again, that's where leading indicators can help us improve our managing performance. Now, safety lagging indicators are reactive measures that track only negative outcomes, such as an injury once it has already occurred. Again, they've been very important. They are still very important, but they measure the past. Okay, safety leading indicators, on the other hand, are proactive measures that measure prevention efforts and can be observed and recorded prior to an injury. Now, the two illustrations over on the right-hand side, in the upper right, we have two people that have run out of gas. They're sitting on the side of the road waiting for assistance. Now, maybe you've had that experience of some time in the past, running out of gas and having to figure out how you're going to get some additional gas to get your car back on the road. All right. Now, keeping track of how many times you ran out of gas is not a good tool to help you understand, will you run out of gas again in the future? And if you've never run out of gas, that's not an indicator that you won't run out of gas in the future and be stuck on the side of the road like these two people are. Now, the fuel gauge in our car is an example of a leading indicator. And if we pay attention to that leading indicator and we don't let the fuel gauge needle get into the red zone, we can be pretty much assured that we would never run out of gas and be stranded on the side of the road. Okay, that's how leading indicators can help us. If we can identify the right leading indicators, they can help make sure that we don't have a bad outcome that ends up over on the lagging indicator column. Now, it's an important point in this. Although we've been using lagging indicators for a long time, and many of our organizations focus strictly on lagging indicators, I'm not trying to suggest that they're bad or that leading indicators are better. What the thought leaders in safety metrics are emphasizing is that it's important to have a balanced approach, that we use both lagging and leading indicators to help us manage our safety performance. And in particular, and for my concern in electrical safety, I see that it's critical in helping us do better in managing our electrical safety programs and the effectiveness of our electrical safety programs. Leading indicators on the left track improvements in risk reduction. Okay, and the lagging indicator, over on the right-hand side, measure the results of risk reduction. These are two different things. Tracking improvements in risk reduction and measuring the results of risk reduction. And so part of our challenge and how we need to think about this is how can we educate ourselves on what do these really mean? In this webinar today, there's no way that you can become an expert in a balanced scorecard. What I'm hoping to instill upon you here is identifying some of the resources that can help you answer this question for your organization. OSHA in 2019 published this document. It's titled, Using Leading Indicators to Improve Safety and Health Outcomes. Now, this is not a regulation, it's not a standard. It's an educational resource. It was targeting the way they structured this document was small and medium-sized organizations that may not have a strong or extensive competency in safety management. Now, no matter where you are on your journey, though, this document could be helpful. And I've listed some of the topics out of the table of contents. This is not all of the topic, but these are a few of the key ones. It has discussion on what are leading indicators. It helps you understand what are the benefits of using leading indicators. One of the key obstacles that many organizations have is how do you collect the data if you want to create a new metric? Well, what OSHA includes in this resource, in this document, is item 3 here, designing leading indicators based on the data you're already collecting. So you don't have to collect something different. You just need to analyze the data in a little bit different way. Number 4 there, this is really important for electrical safety. Leading indicators for controlling an identified and specific hazard. All right. So I showed the earlier pie chart, and you can remember that about 2/3 of the total lost time injuries were attributed to musculoskeletal disorders, sprains, strains, and tears, and slip, trips, and falls on the same level. Having a leading indicator that impacts those probably are not going to be very useful in helping you improve your management of exposure to electrical hazards. So it's important that you have a leading indicator for an identified and specific hazard. All right. Leading indicators to improve an element of your safety program. Your electrical safety program is one element of your overall safety program. All right. And there are examples included in this guide and action plan checklist. Let me point out the next few resources, this one included, they're available to you for free. Just put in your search in your internet browser the title of these, and you'll get them, and you can download them at no cost. All right. Again, this is very recent, published in 2019. All right. This was published by WorkSafe Alberta in Canada in 2020 rather, titled Leading Indicators for Workplace Health and Safety, a User Guide. All right. And again, here are some of the topics out of the table of contents. What is the purpose of leading indicators? What are the strengths of leading indicators? What are some of the challenges in implementing leading indicators? What are your goals? What's your strategy? And how would you know if you're being successful? All right. Again, these are documents that are designed to help educate people concerned about managing safety, although it's broad in a sense that it's looking at safety and health in a very broad and general way. You can adapt and it's intended for you to adapt it to specific risk and specific hazard exposures. Okay, very useful to for managing your electrical safety program. Again, free to download. The Campbell Institute, also known as the Center for Environmental Health and Safety Excellence, is a foundation or an institute within the structure of the National Safety Council. And since 2013, the Campbell Institute has published a whole suite of documents, guides that are related to the topic of electrical safety. Although they're not focused on electrical safety, they certainly are relevant to electrical safety. Over on the left-hand side, designing strategy for serious injury and fatality prevention. Again, as I talked about in the slide on the pie chart, the two sides of the coin. Exposure to electrical hazards has high potential for serious injury and fatal injuries. All right. There's about 20% of the exposures in the workplace have this high potential for serious injury and fatality. Okay, the next one over to the right, beyond safety, leading indicators for health and well-being. In the middle, dark blue, a practical guide to leading indicators, metrics, case studies, and strategies. In the upper top there, in the top, leading indicators from defining to designing. Then below that, an implementation guide to leading indicators. And in the lower right, transforming environmental health and safety performance measurement through leading indicators. Now, again, I want to stop and emphasize that it's not that leading indicators are better. These resources, the OSHA, WorkSafe Alberta, and these Campbell Institute documents tend to be focused on leading indicators. But the reason for that is that lagging indicators have been pretty much the standard in the past. We need to complement the existing lagging indicators we have with new thinking and adding leading indicators. Again, these resources, these are documents that you can download for free. If you just search for the title, Campbell Institute, and then the title of the document, you'll get to the webpage to download them. These three individuals, I value the work that they do, and they're writing articles, they're presenting at conferences, they present webinars. They're widely regarded as contemporary thought leaders in safety and health metrics. Okay, Gary Lopez on the left-hand side there. In addition, he's also currently the chair of ANSI Z16, and I'll talk about that in just a moment. It's a very important standard regarding metrics and leading indicators. Pam Woloski and Paul Esposito are also authors, speakers. They publish in trade magazines and professional journals, provide webinars. And if you want to find a current article on EHS or safety metrics, if you do a browser search for these three individuals, I'm confident that it'll pop up a number of articles or events that they're currently involved in, have been involved in recently that you may have access to. Now, I mentioned that Gary Lopez was the chair of the ANSI Z16 standard. That standard is titled Information Management for Safety and Health. It was originally published in the 1930s, almost 100 years ago, but it was last revised in 1995. It's 26 years without a revision. Now, it was originally scheduled to be published. The latest revision was scheduled to be published last year in 2020. The pandemic sort of got in the way of things, as it's done in a lot of work activity in our personal lives. But that revision is scheduled to be published this year. And one of the features of this new standard, it'll be promoting the concept of a balanced scorecard. In other words, you include leading and lagging indicators and how you manage your safety programs. You can structure this specifically around your electrical safety program as well. Remember, the OSHA guidance was you need to have metrics that are focused specifically on a specific and unique hazard. Again, this is an illustration. I want to emphasize that this is just an example of a balanced scorecard where this is an example where they've looked at metrics related to financial, process, customer, and learning around a safety topic. But again, this is just an example. One size does not fit all. What is most important, and what these resources that I've shown you and the standard, what it will show, is the important work is to think about this, what's unique for your own organization, your own facility, your own workplace, and what makes sense to help you improve the safety performance within the boundary of that, whatever that is, whether it's the corporation, whether it's the business unit, or plant site or work group. So where do you start? Now, if you thought that you were going to leave the webinar today with that Lanny Floyd was going to tell you, give you a silver bullet on a balanced scorecard or leading indicators, well, no, I'm not going to be able to do that, because the leading indicators and the balanced scorecard needs to be unique for your organization, your workplace, your culture. But the way to get started on this is to put your team together. Maybe it's a team of one, or maybe it's your electrical safety leadership group. You may have such a thing in your organization, or your electrical crew, and you start thinking about what can we learn from these resources that I've shared with you this morning, or today rather, and how do we learn from them? Let's study them. Let's educate ourselves on what is the latest thinking on leading indicators, lagging indicators, and how to have a balanced scorecard. So use those existing resources. Now, woven through all of these resources is the guidance that you need to keep it simple. If you make it too complicated, it won't be sustainable. You need to have a start out, at least when you start out, it needs to be simple. The information needs to provide credible information that management, supervision, and workers can understand, value, and support. And remember, what we're trying to achieve here is a balanced scorecard where leading indicators track improvements of risk reduction and lagging indicators measure the results of risk reduction. So we ask these questions. We educate ourselves. We get to start our work. How do we measure management visibility? How do we measure management support to our electrical safety program? We know it's important. How do we measure it? How do we help management understand how well it's doing to support our program? How do we measure exposure reduction? Not just while we're standing in front of the clear and present danger, but while we're doing our planning, our design reviews, our equipment specifications. How do we measure exposure reduction? How can we measure training retention rather than simply training attendance? And what else makes sense to us for helping us in our unique facility and our unique work group to manage the continual and ongoing reduction in risk from electrical injury? I'd like to close with a personal story. In 1990, 21 years ago, in fact, it was early 1990, I'd been working in this topic on this whole arena of electrical safety for a long time at that point. And the vice president of engineering, and again, I worked for a large global company. We had about 100,000 workers and contractors working in our facilities around the world. And he came to me and said he'd like to have an assessment of where we were in electrical safety in our company. Now, I took that as a support from management. And I said, I'll be certainly no problem. I'll get it to you. I'll have it to you shortly, within a few weeks. So after I gave him the report, in fact, I still have it. I've got it right here. It's 31 years ago, but I still have that report here on my desk. It was about 75 pages. I knew he wasn't going to read 75 pages. He needed an executive summary, so I had a 3-page executive summary in front. And he came back to me and he sat down and he said, "This tells me where we've been. It doesn't tell me where we're going. We need better ways to manage how we're reducing risk in all of our plants for future exposure. How can we do that?" That's the question I asked him. How do we do it? And he said, "Well, we need to do it, and that's your job to figure out." Well, fortunately, I wasn't working alone. I had the pleasure and privilege of working with a group of folks that shared my concern on electrical safety. And we got together and we started thinking about a strategy, and we documented that strategy and published it, presented it at a IEEE conference in 1993. And it was titled, "Creating a Continuous Improvement Environment for Electrical Safety." And this was in 1993. And here are the results of how we thought about a strategy to create a continuous improvement environment. I followed this strategy for the next 25 years of my career. About 20 years before I retired. In the first 25 years of my career with this company, we experienced 12 electrocution fatalities. Now, to put that in context, again, we had about 100,000 employees and contractors. 12 electrocutions in 25 years was approximately industry average at that time. In the next 20 years, we had 0. We made a very strategic effort to change how we manage risk to electrical hazards. And we did it not by improving our ability to be in compliance, but to create a continuous improvement environment, okay? Leading indicators weren't the only thing in this strategy, but leading indicators help drive our strategy and help us make a difference. I'd like to show you an example of an evolution in a leading indicator. I was at one of our plant sites and the electrical safety auditor said, you know, I want to show you something interesting. We had been measuring compliance and using GFCIs when we went out on our audits. We'd walk up to some work activity and we'd make a judgment on whether or not a GFCI should be used. And we would check off, was it being used or not? And if it wasn't being used, we'd go up to the work and say, don't you know the safety rules require using a GFCI? So we changed our approach. Instead of asking that question, we started measuring, does the person understand why GFCIs are important? How they save lives when you're working in a damp or wet environment and you have electrical cords or tools or appliances. He said that helped drive understanding of why the safety requirement was there, why we had a rule around. So the worker wasn't just meeting the requirements of a rule, they were demonstrating understanding of why GFCIs were important. And that helped that work site improve its compliance with the use of GFCIs. And that's my last slide, and I'll turn it back to Kevin Parker at this point.
Well, thanks so much, Lanny. I thought it was a very thorough presentation. And what I thought was most interesting was, is there a specific practice or technology that has allowed fatalities to fall from 600 a year to less than 200 over the course of a couple of decades?
Well, a great question, Kevin. And I think that there's no single answer to that. But certainly, we've seen the evolution of OSHA regulations, the continuing evolution of NFPA 70E, for example. That's driving safe work practices. But also, in parallel to all that work, has been an ongoing evolution in the design of equipment, tools, and power system design that has helped reduce risk through engineering design solutions. Things such as the GFCI device. That has made a huge impact on electrocutions involving portable tools, extension cords, and appliances and that sort of thing. Not just at work, but in the home environments too. Evolution in power switchgear, for example, introduction of arc-resistant gear, switch gear that is designed to contain or redirect the arc blast away from where a worker could be standing. High-speed current-limiting fuses is another example. Touch-safe wiring, touch-safe components, the relays, the terminal blocks, other components that go into electrical equipment are utilizing the touch-safe concept that was pioneered in Europe. To reduce the likelihood that a person could accidentally touch an energized part while they're working, doing troubleshooting or working on or near electrical equipment.
Well, thanks again, Lanny. And that's all we have time for today.
Okay, thank you, Kevin. Take care.